You ever wonder why the night sky feels so heavy? Not physically, of course, but emotionally, like it's pressing down on you with the weight of something you can't name. We look up at the stars, millions of them scattered across the black, and we feel small. That's normal. But there's something else, isn't there? Something deeper than insignificance. A kind of loneliness that sits at the bottom of your chest when you really think about what you're looking at. All those points of light, all those distant suns, and not one of them, not a single one, has ever said hello. We've been listening for a very long time now. Decades, generations of scientists dedicating their entire careers to the search. Radio telescopes sweeping the heavens, satellites scanning frequencies, algorithms sifting through noise, looking for patterns that shouldn't exist naturally. We've examined the atmospheres of distant planets, studied the chemistry of far-off worlds, built models and equations and expectations. We've imagined every possible form contact might take: mathematical sequences, repeated pulses, chemical signatures, megastructures blocking starlight in rhythmic patterns. We've been ready, eager even. And the universe has given us nothing: absolute, unbroken silence. Now, I know what you're thinking. We just haven't found them yet. Space is big. We need more time. And yes, space is incomprehensibly vast. But that's actually part of the problem, not an excuse for optimism. Because the question isn't really whether space is too big to search. The question is, why, with billions of years available and billions of worlds to work with, nobody else has made themselves obvious? Why hasn't anyone built something we couldn't miss? Why hasn't anyone reached out? Why does the entire electromagnetic spectrum, across every wavelength we can detect, sound like static and stellar wind and quantum fluctuation, but never once like a voice calling across the dark? There's a word for this: the great silence. And it's one of the most disturbing mysteries in all of science, because the universe, by every measure, should be absolutely teeming with life and intelligence and noise. The math says so. The chemistry says so. The sheer probability says so. And yet here we are, apparently alone, straining to hear anything that might tell us we're not the only ones wondering. Let me take you through why this is so deeply strange. Why the silence isn't just disappointing, it's cosmically wrong. And why the explanations we're left with are more unsettling than comforting. Think about what we know now that we didn't know 50 years ago. We know planets are everywhere. Not rare, not special, everywhere. Nearly every star has them. The Kepler Space Telescope showed us that. Thousands upon thousands of worlds, confirmed just in our tiny corner of the galaxy. Rocky worlds, giant worlds. Worlds in the so-called habitable zone, where temperatures might allow liquid water. Worlds that, on paper, look hauntingly similar to Earth. The numbers are staggering. Conservative estimates suggest there are tens of billions of potentially habitable planets just in the Milky Way, not in the universe, in our galaxy alone. Tens of billions of places where the conditions might be right for something to grow, to evolve, to think. So where is everyone? That's the question Enrico Fermi supposedly asked over lunch one day in 1950. The Fermi Paradox. If the odds favor life arising, if planets are common and time has been abundant and the universe is old beyond comprehension, where are the aliens? Where are the signals? Where are the monuments? The garbage? The accidentally leaked transmissions? Where is any evidence that intelligence has happened somewhere other than here? The paradox has teeth, because the numbers don't just suggest life should exist elsewhere. They scream it. They make our uniqueness seem statistically absurd. Like flipping a coin 1,000,000,000 times and getting heads every single time. Possible, technically, but so improbable it begs for another explanation. And here's the thing: every year we learn more. Every discovery we make about exoplanets and chemistry and the resilience of life on Earth, the paradox gets worse, not better. Because we keep confirming that the building blocks are everywhere, that the opportunities are endless, that nothing about Earth's formation seems truly unique, and yet the silence persists. deepens even, which forces us to confront an uncomfortable possibility. Maybe the universe isn't hiding intelligence from us. Maybe there's nothing to hide. Let's talk about what it actually takes for intelligence to arise. Not just life intelligence. Because these are very different thresholds, and collapsing them into one question is where most optimistic thinking goes wrong. Life, as we understand it, requires certain ingredients. Liquid water, probably, organic chemistry, energy gradients to drive reactions, stable conditions over meaningful timescales. These requirements sound strict, but they're surprisingly negotiable. Life on Earth exists in boiling acid pools, in Antarctic ice, in crushing ocean depths, in radiation-blasted rocks miles underground. It's tough, flexible, stubborn. Once it gets started, it clings on. But getting started, that's the first enormous barrier. We have no idea how likely or unlikely the initial spark is. None whatsoever. We have exactly one data point: Earth. And a sample size of 1 tells you almost nothing about the underlying probability distribution. Life could be inevitable wherever conditions are remotely favorable. Or it could be a 1 in a trillion fluke that happened here through sheer cosmic luck and will never happen again anywhere in the observable universe. We don't know, and that ignorance is crucial. Because if the origin of life is fantastically improbable, if the chemical pathway from non-living molecules to self-replicating systems requires such a specific sequence of accidents that it only happens once per galaxy, or once per universe, then the Great Silence isn't mysterious at all. It's exactly what we'd expect. We'd be alone not because intelligence is rare, but because life itself never gets off the ground anywhere else. Some researchers think this is the filter, the great barrier that prevents the universe from filling up with civilizations. Not nuclear war, not climate collapse, not artificial intelligence gone wrong. Just the brute improbability of chemistry organizing itself into biology. Life emerges on Earth early in our planet's history, which makes some people think it must be easy. But it could just as easily mean we got extraordinarily lucky on our first try, and billions of other worlds sit sterile forever, mixing molecules that never quite catch fire. But let's be generous. Let's assume life does arise fairly often, microbial life, at least. Single-celled organisms drifting through ancient seas, metabolizing, reproducing, evolving slowly under alien suns. That still leaves us an immense distance from anything we could call intelligent. Earth had life for 3 billion years before anything remotely complex appeared. 3 billion years of bacteria. 3 billion years of single cells dividing in the muck. That's not a brief waiting period. That's most of life's history on this planet. And during all that time, nothing suggested that multicellular organisms were inevitable, let alone consciousness. The jump from simple cells to complex cells, eukaryotes, cells with nuclei and internal structures, probably happened only once in Earth's entire history. One event, one merger between different bacterial species that somehow didn't end in digestion or death, but in permanent collaboration. That union gave rise to everything complex: plants, animals, fungi, all of us. And it might be the most improbable event in Earth's biological history. If that kind of cellular fusion is a prerequisite for complexity, and there's good reason to think it is, then most worlds with microbial life never advance beyond microbial life. Ever. They remain bacterial forever, churning through evolutionary time, but never building anything bigger, never crossing the threshold into the kind of organisms that could eventually produce brains and tools and questions about the universe. Another filter, another nearly impassable gate. And even if you clear that gate, even if complex multicellular life emerges, intelligence is still nowhere close to guaranteed. Intelligence isn't the goal of evolution. Evolution has no goals. It's just adaptation to immediate survival pressures. And for the vast majority of organisms, in the vast majority of environments, Intelligence is expensive and unnecessary. A big brain costs enormous energy. It requires extended childhoods, vulnerable infants, social structures to support them. Most creatures are better off being simple, fast, prolific. Bacteria dominate Earth by biomass and have for billions of years. They're going to outlast us by billions more. From evolution's perspective, they're the success story. We're the weird experiment. Intelligence happened on Earth exactly once. One lineage, one branch of primates, stumbled into a feedback loop where bigger brains and better tools and more complex social structures reinforced each other. And even then, it took millions of years and countless extinct hominid species before we got to anything resembling modern human cognition. This wasn't destiny. This was accident. A fortunate, bizarre, fragile accident that might never occur again anywhere else, even on planets with billions of species and hundreds of millions of